This video demonstrates the latest features and improvements of InductEx-LVS. Previous versions of InductEx-LVS were used to perform LVS on relatively small layouts. Significant speed improvements were made to the latest version. We can now demonstrate LVS on chip-scale layouts. Here we have a 5x5mm chip layout. This specific layout contains more than 1.8 million VI connections and more than 650,000 Josephson junctions. Most of these vias and junctions are dummy connections to meet filling requirements. InductEx-LVS will automatically identify these dummy junctions and remove them from the final extracted graph. The main circuit netlist imports all the required subcircuits, contains the pin connections to the layout pads, and contains the connections between the different subcircuits. A separate JSON file is used to define the input settings. Here we import the GDS layout and the name of the top cell. The location of the technology file is also specified. Here we define the main circuit netlist and the name of the subcircuit. The mappings between the layout terminals and the pins of each subcircuit are defined here. This example can be run from the terminal by sending the JSON file as input to InductEx-LVS. Once completed, InductEx-LVS will indicate whether the layout and schematic graphs are isomorphic. In this case, the layout matches the schematic netlist. The output results are also exported to a file in the output directory. This file contains the final mappings between the layout and the schematic graph nodes. We can determine if InductEx-LVS can detect a layout error by deliberately connecting one of the measuring pins directly to ground. If we run InductEx-LVS again, we can see that several discrepancies between the layout and the schematic graphs were detected. The latest version of InductEx-LVS provides better error reporting between the layout and the schematic graphs and will export all the errors to the output directory. As expected, we can see that one of the layout pads are directly connected to ground, which is not the case in the schematic graph. We can also perform LVS on individual subcells in the layout by specifying the cell name in the JSON file and the corresponding subcircuit name. Once completed, the layout and schematic graphs of this subcell are exported as PDF files to the output directory, which can be used for debugging purposes. InductEx-LVS also supports automated compact model extraction of layout cells. The compact model is exported to a subcircuit which can be simulated in a circuit simulator such as JOSIM or WRSpice. Here we show a layout example of an RSFQ OR gate. Extraction ports are placed at the input and output pins of the cell. Additional settings can be specified in a separate JSON file, such as the GDS file name, the name of the top cell, the technology file, and the InductEx layer definition file. Compact model parameters are specified in this block, such as the name of the output circuit file and the name of the subcircuit. The format of the netlist can be specified, example JOSIM or WRSpice. The junction model and the junction parameters are also defined here. External magnetic fields in the X, Y, and Z directions can also be activated if required. This example can be run from the terminal by sending the JSON file as input to InductEx-LVS. Once completed, the error bounds of the extracted compact model is displayed. This GDS file shows the final layout, which contains all the necessary extraction ports required for extracting a full inductance matrix. These ports were automatically added by InductEx-LVS. A graph visualization of the compact model can be viewed in the output directory. The compact model is exported as a JOSIM circuit netlist. This netlist contains a subcircuit with input and output pins as defined on the GDS layout. The subcircuit also contains all the extracted junctions, inductors, resistors, and the full inductance matrix of the cell layout. The extracted compact models can be imported by using the include command for use in larger circuit simulations. Finally, the compact models extracted by InductEx-LVS are far more accurate representations of the layouts compared to circuits designed by hand, because these models contain the full inductance matrix. Error bounds well below 0.03% can be obtained for RSFQ cells and below 0.14% for AQFP cells.